Okay, we have here today an interesting integral. This one's from Caltech Math Meet number 8. We've got the integral from 1 to infinity of 1 over 2025 to the floor function of x dx. Okay, I was thinking this was kind of like the most simple example of what could be a harder problem where we have the floor function, but it's set up pretty nice for us and there's nothing else in here, it's just x. When we have a case like this, usually what I want to do is break up the integral. We can break it up on bounds separated by 1. So we would just do this like an integral from 1 to 2, 2 to 3, 3 to 4, all the way to infinity. And so it's going to be a big sum of integrals. What I can do is let's just generalize one of these, creating the bounds some random n value between 1 and infinity. So we'll create an integral from n to n plus 1 where n's an integer. Then this thing right here, let's write it as 1 over 2025. But now doing it like this, we can evaluate this thing. The floor is just going to round us down. And we know our x values are all going to be between an integer value and an n plus 1. So the floor is just going to round us down to this lower bound of n. And all we want to do is sum up all these integrals to infinity, where the first one's going to be starting at 1. So we'll go from n equals 1 to infinity. But then doing that, this thing right here, this just becomes a constant. Because there's no x in this, n's just a constant value that we could know just walking through this infinite number of integrals. So we can take this out front of the integral. So when we do that, what's going to happen, we have our sum now with this out front of the integral. And then here, we're just going to be integrating 1. And then we can just take care of this thing because integrating 1, that's just going to be x evaluated from n to n plus 1. When you do that, that is just going to evaluate like this. N's cancel. This thing's just a 1. That's going to let us cancel off this integral as 1. I'll just rewrite this sum just to clean it up and make it clear. And because the numerator is 1, we can think of that as 1 to the n and write it this way, so the whole thing is raised to the nth power. This is going to be in the same form as our geometric series. So our formula for that, well, I guess usually we look at this formula starting from 0 instead of 1. So the way we'd usually see it would be this thing. And what we get for it is 1 over 1 minus x. But when we're starting at 1, what we can do is just use the first term as the numerator. So like, because n, we can get a formula for n equals 1. When n is 1, it's just going to be an x. So I can write this as just x over 1 minus x. The only restriction we have on this for convergence is we need the absolute value of x to be less than 1. But clearly no problem here because this thing is way less than 1. So that's going to allow us to just go ahead and use this formula here. So we're going to have this x in the numerator, so it's going to be 1 over 2025 divided by 1 minus this same thing. We can just clean it up. We could do this a couple ways, but let's just multiply in 2025 over 2025 to clean it up. Just multiplying by 1. When we do that, this cancels here, and so our numerator becomes 1. In the denominator, distributing this in, we get 2025 minus 1. Put that together, and for the final solution on this, we just get 1 over 2024, and that's it. Okay, there you go. Quick one from Caltech Math Meet. Thanks everyone for watching. Have a good day.